Hello and welcome to part 6 of QED Stata 2. So now we're going to have a look at this part S17, just going through the same thing for this monthly household income variable. So I'm just copying again these entries, just changing them slightly. So start off by just trying to do that. So it's going to do the detailed stats, do the histogram, see if it looks good. That seems reasonable. Okay. Oops. Look at the stats. So it says recode any missing values before rerunning it. If we look at the reports here, you can see that the smallest, the highest, there aren't any which look as though they've got missing values, so it should be fine. So perhaps that's the answer. However, if we take a bit of a closer look, hopefully you can remember how to do browse, actually look at the data. You can type it full browse. Here's what the data looks like in the browsing window. Quite a large data set. It's one of the last bit of variables, I think, with household income. I forgot I've renamed it Monink. So it's this monthly income. It's a bit hard to make out like that, so what we can do is in the command window, just do sort. Sorts on monthly income, and then back in the browser window. It's slightly easier to see what's happening. Yeah. So there's the nones, there's the high values, but just after the nones, we've got these don't know. So 98 for don't know, and refuse 99. So here, the missing value, really, they've done it quite sloppily, because that 98 and 99 is kind of right, it's much too low. It's round, well, it's in the middle of the actual data in a sense, even though the zeros really are not very realistic. There can't be anybody with zero income. You wouldn't be able to live. So it means they just haven't counted that income. So it's below, but it's quite near to where the main data points are. So if they've chosen a bad set of numbers to use for the missing values, they probably should have chosen the enormous ones, the 999 million or whatever it was. Anyway, we still need to replace them because they shouldn't be there. So here's the commands you could use to replace those, really similar to the last one. So that replaces, and we'll just run those commands again. And there. It doesn't make a lot of difference because it's just got rid of a few down here among all the zeros. But it's good, though. It's more accurate than it was. Okay, now it definitely looks not close to normal. To put a final nail in the coffin of it being normal, we can do the similar analysis to before. So let's see. And this looks random, I've chosen this, but what I'm really doing is I'm looking at the chart and seeing what would be reasonable. I'm looking at here and saying, okay, well, that's the mean. But roughly 2 standard deviations, that's the standard deviation of 4,000, so 2 of those is about 8,000. So it's going to take us to around 12,000, the mean, plus 2 standard deviations. And looking at here, okay, I want to know how many should be over 12,000, what percentage should this be up here somewhere. So I'll calculate it using z-scores and then compare it with what it is if you actually count this. Trying to grab that on these bits here. So put these into the whiteboard. So it's going to be exactly the same calculation again. But now we've got slightly different mean and standard deviation. And now that it's 12,000 instead of 8. So now I've got Z score is going to be the 12,000 my threshold. Subtract the mean, 4313.672, and then divide by standard deviation, 4244.132. Yeah. As before, to actually calculate it, I'm going to go back and use just execute that command again. Just redoing this command from the do file, so that it's refreshed the results in memory, and then I can do this. But now this has to change to 12,000. So hopefully that'll give me there's my Z score, 1.8111. Then as before, I can plug that in through the everything else is pretty much the same. 0.35, so it should be about 3.5% above that. So about 3.5% above this 12,000 threshold. I should put here that X is 12,000 this time. Okay, but otherwise the calculations are the same. So I'm expecting 3.5%. Then let's compare that with how many actually are over that. So I'll just go into the immediate window and just count. Monthly income. If no. Count if monthly income's bigger than 12,000. So 912 cases. And how many is that? Oh, it's mixed up. It's supposed to be the number of cases. Get it manually from here. Oh, it's 1,569. Okay. 629 non-zeros. Of course, we get 912 here for counting greater than 12,000, but there's only 629 observations here, so that's impossible. And the reason is that if you just put counts greater than that, it counts in all of these missing values because they're all counted. The missing values are counted as bigger than any entry, so all those dots are going to be counted in that. So what you have to do is when you do the count thing, so it counts if it's bigger than that, and oops, one ink is less than dot, and dot's the smallest missing value. Yeah, so 31, which is slightly more realistic, and then it calculates 31 as a percentage of the 629. I'll do 100, I suppose. so 4.9. So should have been 3.5%, actually get 4.9%, so there's more than you expect in the higher levels. So it's not as drastic as I expected, but it's a higher percentage than you would expect at those higher levels, so that's more evidence that it isn't normal. It's 4.9 instead of 3.5. Okay, so more evidence there that, as the graph says, as the graph suggests, it's not normal. It's heavily skewed. Okay, so that's how you can analyse distributions and bring in ideas of z-scores and normal distribution. And in the next section we're going to go on and look at correlation, but for now, thanks for watching.